Alright, this lesson is on global winds. Our objectives for this lesson is I will recognize that winds curve due to the rotation of the Earth on its axis, coriolis effect, and that global winds affect the jet stream. I will map global winds to show their effects on climate. Alright, so let's talk about what wind is. So the movement of air caused by differences in air pressure is called wind. So what happens, we talked about high pressure being associated with cold air and low pressure being associated with warm. We know that cold air sinks and warm air rises. So when this happens, you actually have the movement of air, which is wind. Now, you may also hear that winds are caused by the unequal heating of the Earth, which is absolutely correct. Because if you think about how the sun shines on certain parts of the Earth, some parts are warmer than others. So this creates wind because you have warm and cold air, and you have low pressure and high pressure. One important concept that you need to know how winds work is winds always move from high pressure to low pressure. Alright, the coriolis effect. Now this is just the curving of the winds. So the Earth is spinning as air is moving, as your winds are blowing, and because the Earth is spinning, the winds are actually going to curve. And if you look, here's a diagram here, you will see that in the northern hemisphere, because of the spinning of the Earth, the winds are going to curve to the right. Whereas in the southern hemisphere, they're going to curve to the left. So without the coriolis effect, the global winds, which we're going to talk about in a minute, would blow north to south or south to north in a straight line. But the coriolis effect makes them curve to the right in the northern hemisphere and to the left in the southern hemisphere. Make sure you know that. Also, you'll see storms. If you look at the way a hurricane moves, storms actually are going to move counterclockwise in the northern hemisphere and clockwise in the southern hemisphere because of the coriolis effect. And there's a video that I'm going to show you in class today that will kind of give you an idea of why this happens. Because of the winds moving in the right, the pressure changes. And what I have to show you, diagrams are perfect to explain this. Alright, so the global winds. You may imagine that wind moves in one huge circular pattern from the poles to the equator. But, in fact, air travels in many large circular patterns called convection cells. And you'll see in the diagram the pictures of the convection cells. These convection cells are separated by pressure belts, which are bands of high pressure and low pressure. So instead of the winds going a certain direction from the equator to the poles, poles to equator, you actually have these bands of high pressure and low pressure. And there are 3 in the northern hemisphere and 3 in the southern hemisphere. So let's talk about those. Okay, the combination of these convection cells are found at every 30-degree latitude, and the coriolis effect produces patterns of air circulation called global winds. So you have your polar easterlies, which are going to be 60 degrees to the poles, and that is going to be in the northern and the southern hemisphere. Same thing with the westerlies. That's where we are. Remember that. We are between the 30-degree and the 60-degree, and we're talking about latitude. That is the northern hemisphere and the southern. And then you have the trade winds that are near the equator, from the equator to 30 degrees in both hemispheres. Alright, so here's another look at a diagram of these global winds and the directions that they go. You will need to know the directions that they go. So your trade winds are going to go from east to west. Your prevailing westerlies are going to go from west to east. And your polar easterlies are also going to go from east to west. Now, some terms you also may want to know. That boundary where the trade winds meet is called the doldrums, and the boundary where the trade winds and the westerlies meet is called the horse latitudes. Look at this diagram, know it. Alright, so a little bit more about the polar easterlies, westerlies, and trade winds, or global winds. Polar easterlies can carry cold Arctic air over the U.S., producing snow and freezing weather. The westerlies can carry moist air over the U.S., producing snow and rain. And trade winds, early traders used these winds, and that should say winds, sorry, to sail from Europe to Americas. So let me tell you a little bit more about winds. Jet streams, okay? If you watch the Weather Channel, you hear about these all the time. These are going to be fast moving. It's like a jet. It's fast moving air currents in the troposphere. Now, they are also the result of unequal heating of the atmosphere. It's a wind. So jet streams circle the planet mainly from west to east, and the strongest jet streams that you need to know are called polar jets. So these are super cool. Let me tell you why. So think about if you were to fly from Seattle to Boston. Did you know that that could be 30 minutes faster than going the other way from Boston to Seattle? Why? Because of these jet streams. So what happens is when an airplane flies from Seattle to Boston, it's going from that west to east, in which a jet stream, because it's moving so fast, can actually help to push the plane a little faster. As if you were going the other way, though, it would slow it down because you're fighting the wind. And these winds can reach maximum speeds of 400 kilometers per hour. It's pretty fast. Also, jet streams can affect the movement of storms. Meteorologists can track a storm if they know the location of a jet stream.